How is everybody doing today? Yeah, you can hear me. All right. Spring Cloud Function and Infrastructure Consumption Models. My name is Stu. I am the Infrastructure Systems Architecture Geek, and this is Adib.
I'm the Developer Geek.
So we're going to be doing a little bit of a hybrid talk here, talking a little bit about how serverless platforms are built and how a way of thinking about them from a software vendor's perspective that's working on building serverless technology, both for developers as well as for infrastructure. First of all, who's Pivotal? So our mission is to change how the world builds software. Pivotal Labs was founded in 1989 in San Francisco. Extreme Labs in Toronto was another acquisition as part of Pivotal. We are the Extreme Programming Company. We do a lot of agile projects throughout Canada and the United States and globally. And we are a major contributor to open source software. Trying to be number 2 desperately. Everything from Cloud Foundry, RabbitMQ, Spring, Apache Tomcat, we're the primary committer for that. A bunch of JavaScript frameworks you may have heard of, Geode from Apache, etc. So the idea today is there are 2 parts of this talk. We're going to talk about, there are 2 aspects of when you think of functions and you think of serverless. There are 2 ways of thinking about this, and I'm going to show you a preview of some of the work that we're doing here on both of these. One is infrastructure consumption, how to think about this from a bottom up. I have servers, I have containers, we have all this hype around Docker, Kubernetes, platform as a service, functions as a service, Lambda, etc. How do we all fit this all together? The hype is tremendous across the various types of infrastructure. How could we unify this? And then Adib's going to talk more about the programming model, Spring Cloud Function, which is a unified way of separating out the way you build serverless applications and functions on any cloud provider with a standard Java-based programming model that can go basically anywhere. Lambda, OpenWhisk, serverless Kubernetes, which we'll talk about in a second, and Cloud Foundry. Okay, so the way we think about infrastructure today, I'll posit this is that there is a gradient, okay? Most stuff traditionally was at the bottom, infrastructure running on-premise or in public clouds, right? And then we have data services, which is your database servers, Mongo, SQL, RabbitMQ, IBM MQ. Then we move up, we have container systems, Kubernetes being one of the most popular ways of managing containers today. We have application-centric systems like Cloud Foundry or Heroku, where I literally just build my code, I push it to the cloud, and I don't care what happens, right? And then I have function systems where even the actual data sources and data sinks are pre-created and integrated for me, so I just have to focus on the function and the scalability of that code. The integration and wiring of that code is taken care of me by the underlying platform. So it's a very event-driven way of building microservices rather than a full-featured application you might do in a traditional PaaS or a crazy stateful service you might do in Kubernetes, right? So, and then Pivotal has this thing called BOSH that is trying to create the dream that every single one of these can be done with open source software on any cloud. So Google, Amazon, Microsoft, OpenStack, vSphere, you name it, we are running all of these workloads except functions, which is new, it's not out yet, but we're running all these in production in very large enterprises on any cloud. And that is the vision, is that open cloud mindset, rather than getting tied down to a specific provider. So the other way we look at this is that we're trying to, value and time is moving up the stack. The reason we introduced these new models is because we were tired of waiting, right? When we say we're trying to change the world, build software, we're trying to get out of the business of filing tickets and waiting for things to be created for me by the IT group. A lot of our customers are enterprises, and very often it's about all the work going on to wait for bare metal servers to push or scale the application. So we created virtual machines to virtualize that. When correctly and repeatedly configuring the operating system on that virtual machine became a bottleneck, we did a few things, Puppet, Chef, Ansible, etc., but then we built containers on top of that as a way of creating disposable units of deployment that could be scaled up and down on a pre-existing cluster of VMs. Then on top of that, we have things like platform as a service, where instead of managing all the scripts and the configuration, the low-level details of my containers, I really just want to worry about my code. I want to deploy that on the cloud of my choice, and I don't really have to worry about how it's scaled, how it's secured, how it's made highly available. That's something that a scheduler is going to do for me, and it's going to manage for me with all the monitoring and the security that my company wants for me, whether that's on Amazon or it's on my on-premise vSphere or both. And then finally, we move to functions that move this up even a higher level where the middleware is pre-integrated. I don't have to think about that. So if you think of it from a hierarchy perspective, virtual machines on the bottom, then we have containers, and then we have cloud-native functions and cloud-native apps are kind of the ways. And people are consuming these at every single layer, and I expect people will be continuing to consume these technologies at every single layer for the foreseeable future. There is a very busy and noisy marketplace of ideas right now, and it's a great time for innovation if you're an infrastructure geek, and if you're a person who's into how do I handle all the change that's happening. I have so many options, but it can be very confusing. So the way that we try to say, the way to split it is pre-engineered high-level, function-centric, app-centric. Here's my code, run in the cloud for me. I don't care how. That's the haiku that we say of how to think about when you're using those kinds of models. Bespoke low-level models are still important when I have weird specialized things to do. Give me an API so I can program infrastructure to run my code. Okay? Say I'm running a database. I need that. I can't run the database in the other side, right? Say I want to run Kafka or a messaging system. I got to have it on the lower level side. But say I want to run a long-running simulation. Well, that may or may not be function-centric. That might be app-centric, right? But say I'm doing something that is just a very quick function that could run instantaneously. Then definitely that's something to be function-centric. So the idea is that all of these are relevant, and we're still working through, as an industry, what's the right use for each one of them, okay? So Pivotal's vision is an open cloud. Any provider, any program, any model under the covers, whether it's containers, apps, or functions. So for those who aren't familiar, Cloud Foundry, open source project owned by the Linux Foundation. Cloud Foundry Foundation is a sub-project. Platform as a service, you can install it anywhere you want, basically. Kubo is a joint project from Google and Pivotal, and it's an ability to, again, take a Kubernetes cluster and automatically install it, upgrade it, scale it, manage it at scale on any cloud as well, using Bosh, which is a config management, provisioning, and packaging system that is also open source. And then finally, there is Skates, which is pre-alpha. It's about 2 weeks old. You're getting a real preview today. And this is an Apache 2 open source project. It's basically a proof of concept of what we're looking to do with serverless Kubernetes, making a Kubernetes native way of doing serverless code. And this just kind of shows you how it all fits together, where you have your cloud infrastructure, you have Cloud Foundry, you could have Kubernetes next to it, and you can have Skates on top of it. And again, the idea is that it's completely open, it's free, and it's for broad-based collaboration on these kinds of technologies. So I want to demo the POC that we've done for serverless Kubernetes to give you a sense of how this kind of serverless platform might be built on Kubernetes. How many people have used Kubernetes in the room? Cool. So you might get a kick out of this. We'll see. Again, it's pre-alpha. It's a couple weeks old. Mark Fisher from the Spring team is the leader at Pivotal, and it's an incubated initiative. But the idea is to create Kubernetes resources that represent the topics or data for events that can come in from various channels into your functional application. There are handlers, which can be a container image, a dispatching strategy to a particular function, and then the actual function itself, which could be any programming language. The point of this is that this could be everything from a bash script. It could be a Java application, it could be .NET, it could be Python, it could be Ruby. it doesn't really matter. A lot of the bindings are going to be platform agnostic using things like environment variables. It's CGI all over again, yay. Okay. So let's show you skates. Let's show you my beach ball. Okay. So I have just to show you what I have here actually. So this is on Google Cloud, Google Compute Platform. So I have a Cloud Foundry instance sitting here in Google, and I have a marketplace of services. I have an autoscaler, a Rabbit, MySQL, and I have a Kubo cluster, which is Kubernetes. And I've created a Kubo service. It takes about 10 minutes. Launches a bunch of virtual machines. I have a Kubo service if you want to see it, just to show you that this is, there are no nets here. This is actually live. So I got a bunch of virtual machines running. There's a broker, and then there's my Kubernetes cluster, and it's a fairly beefy one that I created last night. Okay, so I have this set up here, and this is actually hooked into my Cloud Foundry, so it's pre-wired with a Google Global Load Balancer. It's pre-wired with my Cloud Foundry router. So no matter what I build, if I build an app in Cloud Foundry, I build an app in Kubernetes, I build a function with skates, they're all going to be able to talk to one another. They're all going to have the same networking configuration and the same security configuration, because they're all kind of deployed in an integrated manner. Okay, so to launch skates, I haven't deployed skates yet. I'm going to do that. The first thing I'm going to put on is a Kafka cluster and a Zookeeper cluster. So let's go ahead and do that. Oh, can't, not Apple. Apply. All right, so Kafka and Zookeeper is created, and you're going to see as I type, things will magically appear on the left-hand side because I'm monitoring the state of my Kubernetes cluster. At some point, they'll show up. And let us put on skates. Okay, so those are all created. And we're starting to see things pop on the other side. So we see Kafka's up, we have a topic controller and a gateway and a function dispatcher. So we have a gateway that it gives us a REST interface into posting to topics. It could be other gateways that map to, say, RabbitMQ or Kafka or whatnot. We're using Kafka as the substrate inside. So we have a global router for all incoming events for various endpoints that can be spawned up. And then they all get routed through Kafka and then dispatched to the actual underlying function that we're going to register. So to show you this in action, I'm going to register a topic. So just to show you what this is, for those who are Kubernetes geeks, you might get a kick out of this. So we have a words topic, and it's fairly simple right now. There's not really any parameters, but it's just it's a custom Kubernetes resource. So we're going to create that. And you'll see that pop up there. The words topic is just another object, along with pods and services and jobs and everything the way you otherwise would have inside Kubo. And then we're going to create, and if you actually look here, I'm going to show you the code for, this is a bash function actually. It's just going to be a very simple echo function that echoes the message which we're passing today as an environment variable that will then be piped out to a file. But the idea is that there will be a variety of ways of passing context. Environment variables will be one of them. There'll be others that will be language specific as we evolve this, such as with Spring Cloud Function, which Adib's going to show you in a moment. So once we've done this, let's create this echo function, and let's label the gateway so that it is exposed on my front router. So you can see that the function is there and the route is exposed, port 3111. And I'm going to do a curl There it is. And we'll put a hello world there. There we go. And you'll see here that all of a sudden it's a pod popped up that is going to be our function, and it's actually today mapped as a Kubernetes job. So every time I do this, it's going to basically do an auto scale out of a bunch of Kubernetes jobs, launching pre-warmed containers that are going to jump out jobs as I deploy them. Okay, so this gives you a sense of the early stages of skates, being able to react to events, being able to have Kubernetes native resources for data as well as functions that are then give you a vast amount of choice under the covers for how you implement the dispatching, how you implement the scheduling. We think this is going to be very exciting. And it's on GitHub. It's a very early stage code. It's just, again, was announced, but wanted to show it to you today. I thought it might be of interest for those who are looking for serverless platforms. All right, with that, I will switch to Adib.
Sweet. Thank you. Hello. Okay, cool. I should probably turn on my mic. Can you guys hear me better now? Sweet. Okay. So I think the message we're trying to communicate here is like remember the two aspects of functions, which is like, there's the infrastructure that you run it on, and that infrastructure should not be restricted to public clouds. You should be able to do it wherever you want. Similarly, with with Spring Cloud Function isn't about the infrastructure, it's about the code and how you write the code. So basically, just a quick check. I expect everybody here to not be a Java developer. Who is not a Java developer? Raise your hand. Okay, the majority of the room, right. Okay, good. So you guys are probably going like, Java developers, how is Java going to actually compete in the function space? I think it's going to compete fairly well. So a little bit of background. There's a project called Spring Boot, which is a cloud native. It's all about cloud native microservices for Java. It's very opinionated. There's no XML. I'm going to do a bunch of live coding in a few minutes and build up a Spring Boot app. Then we're going to build up turn it into a function. Then we're going to turn that responds to HTTP. Then we'll turn it into a function that responds to messaging via Rabbit. So we'll do a bunch of stuff with it. That's kind of coming. So essentially, this is what you want to be using if you want a really rapid environment where you can work with Spring. It's very popular now. We're pretty close to 20 million downloads a month. And this is the part about Spring Cloud Function that I kind of want you to the model I want you to have in your mind. The basic concept of and the idea behind that the Spring team is very proud of is like the programming model should not restrict where you run your code. So for those of you who have been in the Java world in the past, people originally started using Spring because it isolated you from the app server and your code could work in WebLogic and WebSphere and JBoss and Tomcat and all these places. We're doing exactly the same thing with functions. We're like, hey, if you write a function in Spring Cloud Function, you should be able to run it on Lambda. You should be able to run it on OpenWhisk. You should be able to run it on Kubernetes. You should be able to run it on Azure, on Google Function. You shouldn't care. As a developer, you should just really focus on the code that you want to do. And so what I'd like to do is, rather than talk more about it, is just do a live coding demo. So I'm going to switch over here to my IDE. I hope everybody can, the font's big enough for everyone. I hope, wave in the back if you can see the fonts. Nobody's? Okay, cool, excellent, thank you. All right, so I've got here my IDE. I'm going to go, hey, create me a new project. And you'll see here I'm using something called the Spring Initializers. For those of you who haven't used Spring before, I'm going to click Next. I'm going to call it, hey, I want it in the COM example. Let's call it functions. It's going to be interesting typing at an angle. I'll probably make a few typos. Functions demo, click Next, and I'll say, hey, look, just make me a web app. And let's add some Rabbit to this. Next. It says, hey, where do you want it? I'm going to leave it in this directory here. Click Finish. Let's make a new window. So what's going to happen here is I'm going to end up with the code for my app. And let's take a look at it. Oops. This is it. I have a main method. I've said this is a Spring Boot application. All I need to do is click here, run it, and I'm going to end up with an app server up and running. And it does come up fairly reasonably quickly for a Java app. So you'll see this one here is now running on port 8080. So what I'd like to do is take this application and turn it into a function that I can deploy to a variety of infrastructure. But first, like when you're coding these functions, I think as a developer, I want to be able to run any of them on my laptop. I want to be able to do it using the standard way of doing things. I don't want to have to do anything crazy. So in the Java world, if you think about functions and functional programming, there's a standard set of utility classes. One of them is called function, surprisingly. So I'm going to create a method, and it's going to return a function. We'll start with a string to a string. Let's call it example. And we'll just do a lambda here that's just going to return. Yeah, we're just not going to do anything other than this. And we need to import this guy. Okay. And then all I got to do is go like this. And what's going to happen is that Spring is going to notice that I have defined a function and is going to expose this as like an equivalent of a lambda. It's something I can now call remotely. I don't need to assign kind of URLs to it or anything like that. It just basically says you have an input, you have an output, therefore you're an HTTP post, as an example. You guys with me so far? Let's make it a little bit more interesting here, and let's just not have it take a string, an input string and an output string. Maybe we want an input JSON, output JSON. So I'm going to use the rather creative foo and bar. All right, so let's have private string value. Again, typing at an angle is not very easy. And we'll do a constructor. And this is Java, so we have to do getters and setters. And Jackson really wants me to have a empty constructor, so I'm going to do that. And then I'll do also a bar that I'm going to return. And we'll change this guy to be, I give you a foo, and I'm going to return a bar. So now I need to change this guy here, and let's just do, I take a foo, and I do a new bar, and we'll take the foo dot get value dot to uppercase. Okay, so pretty simple function, right? Now what I'd like to do now is let's just reboot this guy. And if all is well, I should be able to ping it from Postman and actually send it some JSON and get back a new JSON. So, oh, actually, hold on. I have not done anything. I haven't introduced a Spring Cloud function project yet. So the way that Spring Boot works is you add a dependency to your class path, and it will automatically configure that. So what I need to do is I need to go here to my pom.xml, and I need to add the Spring Cloud function. Now, given that the Spring Cloud function is not yet GA, it's in the snapshots repository for Spring. So I'm going to cheat a bit. I'm going to copy and paste the correct pom.xml, which is going to have what we're looking for, which is from this one right over here. Okay, this is in fact the correct project. Let me check. Yes, this is the one I've been working in. So we'll go here to pom.xml. Let's just paste this guy. And all I've done here is I'm going to, okay, let's switch this to be web. So what I'm doing is I'm adding this code here, which says, hey, Spring Boot project, I'd like to use the Spring Cloud function web as my as part of my dependencies, please turn this Java function for me into a serverless function. Okay, cool. So I'll restart this. So what's going to happen now is I'm going to go over here, and if everything is working, I should be able to just send my value and get it back. All right, let's change it to there you go, right? So you're getting, I hope you're getting the idea here that when I write my code for my function, I should not be depending on any SDKs that aren't kind of like, that are unique to a particular provider. We really want you to be able to write using whatever is in the JDK, whatever is in Spring, if you happen to be a Spring user. That's why the project is called Spring Cloud Function. Now, the interesting thing about Spring Cloud Function is that I can basically say, okay, I have here a Spring Cloud Function web, and you saw how I was sending a web request and getting back a web request. But what if my functions actually wants to respond to like RabbitMQ messages? What would I need to do? Should I have to change anything in how I've written the code? Absolutely not. So I've got a short demo of this here. Let me just, in the interest of saving typing time, I'm going to switch over to this guy here. Same exact code that you just saw. But now I've added another type of function that you can write with Spring Cloud Function, which is you can use the supplier interface, which says I produce a result. I don't consume any input. So this might be something that responds to like a GET request if it was an HTTP endpoint. But what I'd like to do is I'd just like it to say, hello, the time is whatever the current time is. And so I'm going to start this guy. And one of the things I've done in this one is I've switched it to use the Spring Cloud Function stream. So in the other one, I was using function web to say that's a function that's expecting web requests. In this case, it's expecting a stream of messages. So I'll take this, and I will go to my web browser, and let's take a look at my RabbitMQ here. I've got a queue called results where I can see what's happened. Let's just check that there's nothing here. Let's purge that queue. Okay, queue is purged. And I've got a queue called foos where I send my input. So what I'm going to do is publish a message. And if everything worked, and I hope it does, when I get message, oh, queue is empty. Queue is empty again. Okay, live demos. Let's reboot this guy. What happened to this? To-do. Ah, okay. There we go. We had some messages hiding there before. Seems like I forgot to restart it after I changed something there. So hello, the time is 14:17, blah, blah, blah. You guys get the idea here? So when I write my code and if I'm writing a function, I should just be able to do basic stuff. So let's go back to...
So Adib, what you're basically saying is that you change your make file and you move from a queue to, from a web to a queue.
Yeah, it should be that easy.
Okay, interesting.
Yeah. So, and this is kind of interesting. So kind of going back to what is the three things you can do with it. These are the three functions from Java util we use: consumer, supplier, and function. Consumer will consume something without producing a result, like say reacting to an incoming message and doing something against the database or running a batch job. Supplier will produce something without any input. Function will take an input and produce an output. And so we saw already this code, so I'll skip over it. So basically what happened was that my code was, I was getting the HTTP request. It was going to Spring, which was then sending it to my function bean. Similarly, when I added stream, I was getting it via the stream. Right? So a little bit of, so you want to talk about how this works on the Kubernetes clusters?
Sure. So the way that Spring Cloud Function works is that it dynamically will compile your function code as well as allow you to do static uploads. So what Adib was showing you is the local development experience, but if you deploy this on, you can deploy this in a variety of different contexts. One is Lambda, one is OpenWhisk, another one is Fission on Kubernetes. The idea is that you have a pre-warmed pool of containers that are going to have a basic Spring Boot app pre-warmed inside of it to get rid of the Java kind of overhead of launching for the multi-second launch. And what you basically have is one server that's going to, you have just a basic function that could just be effectively a Java Lambda. What will happen is you post that to a function registry. It will compile that bytecode and then upload that bytecode into these pre-warmed containers in Fission, and allow you to do effectively very, very fast startup of these functions and invoke them multiple times. You want to go to the next one. So effectively, the idea is that you have this generic code that is in your Spring Boot that's kind of like, there's no code gen, it's just that main method that is kind of a sitting container warmed there, and then you just inject this code on top of it, on top of this pool, and then you can map triggers to it. With Fission, you actually have the ability to map MQ events. They support a message queuing system called NATS. Another one is you can map HTTP events to the same thing, and under the covers, it's just going to dispatch it to the function that you uploaded dynamically. And this gives the ability to have Java code with a similar experience to like dynamic code, like a Ruby or Python or whatnot, with similar startup times.
Yep. So one of the things I forgot to show you is that same function running on Lambda. So here it is on AWS Lambda. Let's click test. I think it needs to warm up. So while we do that, I'll actually show you the code. So what do you need to do to make this run on AWS Lambda? Again, you don't change your code. So this is kind of just straight out of the samples project. There's a Spring Cloud Function Adapter sample. And what happens is that you add AWS, like Spring Cloud Function Adapter AWS, to your class path. And you're basically saying, hey, take my code and make it work as an AWS Lambda. So the idea is you write your code, you manipulate your make file, your build file, and based on how you manipulate your build file, the code adapts itself to the various environments that you could run it in, giving you the ability to run that code on an app-centric platform like Cloud Foundry with a CF push, or on a server, on your laptop, on your build server. Like all of the things that you would normally want to do should be fairly easy to do. Let's go back here and click test again. I think it always times out on the first time. Takes too long to start, I guess.
Oh, this one's failed.
All right, let's try it again. Try it one third time. If it doesn't work, we'll move on. It was working earlier. So
the demo gods have smiled upon us thus far, but not this day. Okay.
All right, it's cool. Well, I'm gonna wait for it to either fail. Okay. Sorry, guys. It is failing with. It was working earlier. You'll just have to promise me that it does. All right. So moving along here, I got a couple of more, kind of helping you put it in perspective of what do you need to do as developer building functions. So functions and reactive programming. How many people here are familiar with reactive programming? Raise your hand if you are. Raise your hand if you've never heard of reactive programming. No, nobody. Okay, 2 people haven't. All you need to know in the context of functions is reactive programming and function as a service and is like peanut butter and jam. They kind of go together. So that raises the question, if I'm going to build functions that are going to compose and call a bunch of other things, how am I going to do that in a reactive way? Well, this is part of the Spring Cloud function being part of the Spring ecosystem has some answers for that. So in the world of the JVM, there is a standard called reactive streams, which was agreed upon by a variety of various library authors, including Akka and RX Java and Project Reactor and others. And the idea is to say, if I have code written with one framework, it should be able to interoperate with code written in another framework that's reactive. On top of this reactive stream, there's something called Project Reactor, which is implemented by the Spring team, which gives you the ability to build reactive systems with Java. It's built on top of reactive streams. Project Reactor does not depend on Spring. Okay? Spring depends on Project Reactor. So if you want to use it as a reactive library, you can just use it as a reactive library and never touch anything from Spring. So in the world of Project Reactor, there's two kind of basic data types, a flux and a mono, and this is how you kind of write your reactive code. I've got some diagrams to explain what a flux is. It's basically a stream of events that are coming at you, and then you have some sort of operator that does something to this event stream. Now, the value of frameworks like Project Reactor is that you can take these streams of events and operators, you can compose them. And by composing them, you're able to do some really wonderful fast processing asynchronously with all the kind of the benefits that people want from reactive, things like back pressure and various other cool things. A mono, on the other hand, is just something that has one value in it rather than a stream of events. This is what, for example, a function written with the flux and mono, the reactive function would look like. If you see here, it's the same thing. It's going to go to uppercase, but this time what I'd like to do is I'd like to add a step to check if filter out all of the strings that aren't root, right? So I have a flux which is going to call going to have in its operational chain a filter that's going to reference the function this dot is not root, which is going to do something that tells you whether the text is root or not, and then I'm going to map that to something with uppercase. So instead of this being something simple like this, imagine that what I've had here is something that called another function, called another service, got a whole bunch of stuff executing in parallel, and then gathered the result up as something that the function returned. Now, the thing about reactive, it's a bit of a virus. Like, you need a reactive data source at the bottom. So if you're using Redis or Mongo or like a Postgres or whatever, you need an actual reactive data source that understands the concept of reactive. Once you have that, you're going to need to write a reactive data access layer. And for that, we have reactive support in Spring Data. And then on top of that, I need to now write actual processing logic that's reactive. You can use Project Reactor for that. And then you need a reactive web stack at the top, and that's what's coming out in Spring 5, which will be released in September, which is Spring 5 WebFlux. So if you're into reactive, I think you'll find that Spring Cloud Function will give you a way to write code in a reactive way and then run it on any of the function platforms that are out there. These are some resources you can kind of go to kind of dig more into Spring Cloud Function. Questions?